Bismillahirrahmanirrahim. Welcome to topic 4.3 multi-threading model. Okay, the purpose for this topic, we will discuss about the relationship between user threads and kernel threads. Okay, threads can be supported at user level or kernel level. If the thread is supported at user level, it is known as user thread. So for user thread, the management is done by thread library. Okay, in this outline, we will focus on Java thread library. Okay, for thread that has been supported at kernel level, it is known as a kernel thread. So it is supported and managed by the OS. So for example, all general OS support kernel threads, including Windows, Linux, and Mac OS, as well as for mobile devices, iOS and Android. Right, so to execute on a CPU, a relationship must exist between user thread and kernel thread. So the common way to establishing the relationship via multi-threading models, okay, there are 5 type of models. Okay, the common one is many-to-one model, the one-to-one model, the many-to-many model. The fourth one is two-level model and one-to-many model. However, we only discuss only 4 models. Okay, we start with the many-to-one model. Okay, this model map many user thread, okay, to one kernel thread. Okay, the thread management is done by thread library in user space. Okay, the drawback of this model, if one thread makes a blocking system call, it can causes all thread to block as well. Okay, so the another drawback, since it's only allow one thread to access the kernel at the time, so multiple thread may not run in parallel on multi-core system. Okay, so very few of system currently use this model because its inability to take advantage of multi-computing core, which has now become standard on most computing system, right? So for example, Solaris screen threads and GNU portable threads has used the many-to-one model. Okay, the second model is one-to-one. So this model maps each user thread to kernel thread. It provides more concurrency than the previous model by allowing another thread to run when a thread makes a blocking system call. But the only drawback for this model is that creating a user level threads require creating a corresponding kernel thread. Thus, a large number of kernel thread may burden the performance of a system. Okay, so for example, Windows and Linux use this type of model. The third model is many-to-many model. So this model allows many user level thread to be mapped to a smaller or equal number of kernel threads. So it allows the OS to create sufficient number of kernel thread. So the last model is two-level model, where actually it's combined the approach of a many-to-one model and many-to-one model and one-to-one model. Okay, so it's that is all for multi-threading model. Inshallah, we will continue on Java thread library on next video. Thank you for watching.